So hello everybody, and welcome back. And yeah, I hope everybody was able to make use of that 15 or so minutes that we had to go and use the networking area of the platform and to make some new connections. So yeah, I hope that was useful. Hope you were able to do that, and hope you're all now back with us for the next session. So we started today by looking at the low frequency bands, so looking at the spectrum bands below 1 gigahertz. We're now moving up the frequency range, so to speak. So we're now going to be looking at the mid-spectrum bands. So this next session is going to be focusing specifically on the bands from the ranges 1 gigahertz to 10 gigahertz. So lots of very sought after frequencies within that range. So really looking forward to the discussion here. So without further ado, I'd like to pass the floor to our moderator, to Amit Nagpal from Ether. Hi, Amit.
Hi, Dan.
Hey, good. And yeah, really looking forward to the session. As I said, we've got an excellent panel and lots of issues to discuss. So over to you. Looking forward to it. Thank you.
Great. Thanks, Dan. And can I say thank you very much to the CITC and ITU for giving me the honor of moderating this very interesting session. So as Dan said, we're going to be talking about midband spectrum, the middle sort of session of the day. And there's a lot of discussion, first of all, about what do we mean by midband spectrum. And I think for the purposes of this discussion, let's treat it in its widest sense, in the sense of let's go from the range sort of 1 gigahertz to 10 gigahertz. That said, I think a fair amount of the discussion is going to focus on the 3.5 gigahertz band, as that very much seems to be the sort of key global band for 5G at the moment. But I think it's important that we also, as part of this session, first of all, consider other frequency bands, for example, the 6 gigahertz. And also, although sort of there's a great focus on 3.5 gigahertz, because of its sort of being seen as the sort of key pioneer band for 5G in many geographic areas of the world, I think it's important to remember there are other uses of the spectrum. In fact, there's a lot of other existing users in that spectrum, which are providing very valuable services. So finding means of coexistence and working together is going to be absolutely key in the 3.5 gigahertz band and in other bands. So for this session, we have 4 great speakers. We're going to cover a variety of perspectives. And also as part of this, we're going to also basically look to get input from all of you through the sort of chat function. So any questions that you have, please post them up. And really, we have just slightly less than 1 hour. So I think, just in the interests of time, we'll ask all the speakers to be relatively brief and concise in their opening remarks. And once we've gone through the opening remarks, I will look to move straight on to the questions that come in from the audience. So to just briefly introduce each of the speakers, first of all, so we've got Alexander Kern, who is from the BNetzA, the German regulator, and I'm sure he's going to talk about sort of the perspective across the whole midband spectrum range from sort of perspective of a regulator. We have our next followed up will be Artie Holler, who is Secretary General of ISOA, the Satellite Operators Association. And I think one of the things you'll be talking about is satellites' existing use of the midband spectrum and the importance of that. We then have Fatima Karim Peters from Huawei. We'll be talking, I guess, from the sort of vendor perspective, but very much focused on 5G. And then finally, we will have Jennifer McCarthy from Federated Wireless, who will talk to us about sort of this important issue of sharing spectrum and talk about some of the different models and approaches that can be used to sharing. So yeah, we've got 4 great presentations coming up, and to start us off, over to you, Alexander.
Thank you very much, Amit. Thank you very much to CITC and to the ITU for providing me the opportunity to speak to you today. I would like to get you some introduction into the midband spectrum and also our regulatory views on that one from an international perspective, but also from the national perspective. So first slide, please. That would be very kind. Yes, you see here that the midband spectrum is always changing, and if you look it up, you have some downwards area. We start here, as Emmett pointed out, at 1 gigahertz, and you go to 10 gigahertz. You can also address it a little bit further, up to 24 gigahertz. but our session here is dedicated to that one. What is mid-band spectrum is an undefined term for me because, well, I would say 5 years ago, mid-band spectrum was only between 1 and 2 gigahertz, and the high-band spectrum was at that point in time the 3.5 gigahertz spectrum. However, the questions on that one were always the same. We have the lower frequency, so around 1 gigahertz, where we have more coverage, which is, and less coverage in 10 gigahertz, or you have more network density, which you need there. That needs to be taken into account from a perspective of the regulator. And of course, you need to take into account that you have maybe broader channels, so therefore more capacity. What you see as well, if you look here to this slide I made for you from 1 gigahertz to 10 gigahertz, this shows you or indicates the different allocations overall the band up to 10 gigahertz, and which we have currently in the radio regulations, and only the primary ones. So you see that sharing is nothing completely unusual, and in particular not in the higher frequency bands. You may have some more broader channels there, but you need to have the specific interest for certain elements as well. And we are happy that we can discuss now in a more different environment also the different opportunities here to provide more bandwidth for different services. And that promotes, from our understanding, then the innovation which is necessary to move up. So going up into higher frequencies, and in particular the mid-band, provides some maybe the balance point of view, which is currently the trend for different services. And Amit mentioned already there the 3 gigahertz bands, C-band, where we have some balance between satellite and terrestrial services. And this question will be also raised in the 6 gigahertz range. If you move forward to the next slide, please, I have pointed out some challenges. So what is from the regulatory perspective or regulator's perspective is element here is, do we need something and more in the satellite perspective? Do we have more demand from the terrestrial perspective? Do we have the possibility to balance both? We have, of course, the question of the authorization, which needs to be taken into account. Is it a licensed approach? Do we need to have an unlicensed approach? Both are addressed in different perspectives. And of course, you need to take into account, do we have the protection of the incumbent services? Do we need to have some kind of exclusivity? From my understanding, the higher you go into in the frequency range, the more a question of what towards sharing is essential, and it provides also the opportunity, either in different ways, because you have either no longer the opportunity to have really a nationwide coverage in an area of 10 gigahertz, you have more a hotspot usage, and you need to have a very dense network if you would like to do it on a nationwide point. So therefore, you have, from a geographical perspective already, a very good opportunity to share, but also maybe from a perspective between the different services. So therefore, you have maybe to find always a new balance between the newcomers and the incumbents to see that. And we see here the trend that this particular mid-band spectrum is now absolutely the current state of play for the discussions we are looking at. And if you look into the different bands, then please next slide. Then we have, from a WRC perspective, and these are the indications you have here, only 2 bands from a worldwide reason, that worldwide range. That may be not sufficient for some, but it shows also the trend that you need to have particular bands for particular demands. From a worldwide stage, of course, 3.6, 3.8 is the global discussion we are aiming at, and you will hear from my colleagues in the panel maybe more details on that one. But it shows already and indicates that you need to find a balance between terrestrial and satellite. Europe has taken its approach on that one, you know that, and therefore we are moving forward. Germany has taken the approach there as well to find a balance between newcomers, verticals, and incumbent services between 3.6, 3.7, and the 100 megahertz for 3.7, 3.8. So BNetzA is quite happy that we are moving on to more interest into the 3.7, 3.8 megahertz band, and our approach to provide here on an application-based process something to the verticals and the industry that is really a system which is moving on and which is really growing. Another band I would like to speak here is only the 100 megahertz band between 7025 and 7125, which is, from a worldwide perspective, the only band on the agenda for WRC 23 available or is foreseen for IMT. The rest of the band below that is only for a regional basis, because we had discussions here as well, as this is the complementary band to the 3.5 gigahertz band from a satellite perspective, that you need to find, again, a good balance for the uplink spectrum. this particular point is then on the other side, the corresponding band 6425 to 7025, where we need to find also the balance between maybe some usual unlicensed usage in the US and then in Europe and others where we have downwards the linkage for new Wi-Fi spectrum, which is more indoor. Do we have the possibility to have relay outdoor here as well? Is this some kind of border? So I'll leave this question open for the later discussion. Then for the regional and national issues, we have, of course, 3.3, 3.4, which is at some point in some particular countries a band which may be used for further IMT spectrum, but in Europe and other countries, this is definitely a no-go. I said already 3.4 to 4.2 is a band which may be considered on particular issues, and we need to find a balance here as well. And we have also for the WRC 4.8 to 4.99, which is already in use in some countries in Asia and in Africa, but which gains attraction to others as well. And also from BNet's A perspective, this band doesn't provide enough bandwidth there for our purposes, which we would like to go forward, in particular for larger channels. But I'm open for any questions in that direction. If you look beyond the 10 gigahertz range, there is one band which needs to be covered as well. That's 10 to 10.5. There are, due to the usages, also some challenges to be made in order to move forward for some kind of IMT usage. And there is still a doubt that in Europe, this band will really get enough attraction to move forward. But maybe we find some intelligent sharing usages to make it happen. But from our understanding, we need to move forward. And of course, the 3 dots indicate this is not the end of the story. These are the current bands under consideration, and we are moving forward. So with this slide introduction and our perspective, I'm happy to answer any question and give the floor back to Emmett. Thank you very much.
Great, thank you very much, Alexander. I think we'll take questions sort of at the end of after everybody's presentation, but thank you very much for that great overview presentation. I think you covered a lot in your sort of 6-7 minutes. And I must confess, I had a particular smile, sort of big smile on my face when you made the first point about what we mean about mid-band spectrum is very much a moving target. It certainly has changed over time. Okay, let's move on to our second speaker. So just to repeat, this is Artie Holler, who is going to speak to us about satellites use of mid-band spectrum. Over to you, Artie.
Thank you, Amit. Very nice to be here on behalf of the satellite operators. If I could have my slides. So the next slide, please. I wanted to talk to you about where satellite is using mid-band. Obviously, we start with the C-band, and then we'll come on to the KU. C-band usage is extensive around the world, either in business-to-business form or business-to-consumer. And in different parts of the world, the satellite operators are operating under different regulatory conditions. They provide really a wealth of services to the everyday in terms of internet access, TV broadcasting, distribution, mobile and Wi-Fi backhaul, to the critical. So we're talking about peacekeeping, disaster relief, aviation security, and so on. We do see that the usage continues to increase as certain applications are becoming more demanded, especially as usage patterns are changing in the current climate. Next slide. I wanted to give you some examples, and these are not SOA slides. These are slides which were presented by some of our users at the WRC 19. The first one is from UNHCR, the refugee agency, and I've highlighted in yellow there their statement about C-band, that UNHCR continues to use today nearly 300 megabits of space segment, primarily C-band and KU band, so they use both. I think it's also worth noting that in spite of their great expectations, the following bullet, they don't expect to be able to rely on 5G either in the short or the long term because of coverage concerns. So they do have real concerns about changes to the way they use these bands. Next slide. Another example is from MultiChoice, a broadcaster in Africa. And this is just, you can see 3 images of C-band Earth stations in Africa. The middle image is below 3.8 gigahertz, and the third image is from 3.6 to 3.8 gigahertz. And it's worth noting that the number of Earth stations have increased since this presentation was given. Next slide. The next example is also presented at WRC. This is about aviation safety, and it was presented by ASECNA, the Aviation Safety Association in Africa. And the basic point there is that they have so many VSAT networks which are supporting air navigation and meteor services that, in fact, it's impossible to land a plane in Africa without using C-band because of the lack of infrastructure. Next slide. So the question is whether IMT demand for C-band spectrum needs to be contiguous or aggregated. We know that MNOs say that they need at least 80 megahertz of contiguous spectrum. And in most countries, you have 3 to 4 national mobile operators. And so making 200 to 300 megahertz available should normally allow each one to have somewhere between 60 to 100 megahertz. Ofcom, the UK regulator, has researched this, and they concluded that, in fact, the majority of benefits to the economy and users is, in fact, realized through MNOs first deploying 40 megahertz of C-band spectrum. And there was no evidence to show that 5G could not be delivered with smaller, for example, 40 megahertz blocks or non-contiguous carriers. This is also supported by the ITU's report M2410, where they note that aggregation across multiple bands is possible without the need for contiguous spectrum. So I think it's safe to say that having 80 to 100 megahertz is not a real requirement in terms of contiguous spectrum for MNOs to deploy 5G. Next slide. The other issue for us is, of course, topic 9.1c, which is studying the use of IMT for fixed wireless broadband in bands allocated to the fixed service on a primary basis. And here I'd like to highlight that, in fact, the fixed service is primary in all FSS and BSS allocated bands, including the midband spectrum. Now, the reason for this is historical. Of course, point-to-point connections can coexist with satellite. But now we see that vendors have started to promote 5G technology being put onto existing towers. And there we are moving away from point-to-point, and we start talking about point-to-multi-point connections. And that is something which still needs to be studied because of the risk of interfering with existing FSS Earth stations. The resulting interference could, of course, cause loss of vital satellite services, which are relied on by millions around the globe today. And that's the end of my presentation. Thank you.
Great, thank you very much, Arti. I think that was a very good overview of some of the existing important uses of the spectrum that's under consideration, and also a little bit of discussion about how much spectrum the mobile industry does need for 5G, which I think takes us very nicely onto our next speaker, who, as I mentioned earlier, is Fatima Karim Peters from Huawei. And over to you to present, I suppose, the vendor view and the demand for spectrum for 5G.
Thank you, Amit. Thank you. And first of all, I would like to thank our friends and colleagues from ITU and also from CITC for this exceptional event. I'm really pleased and honored to be part of this distinguished panel. The only thing we're missing is the dates and the good coffee from Saudi, from KSA. But that's maybe something we can basically keep for after this COVID crisis. So without waiting, I would like to ask, please go to the next slide. So one of the questions that has been asked regarding on this session is how can we basically fulfill the different needs from different users? And what this slide is showing is that 5G is basically serving needs from different kind of use cases, different kind of businesses, and different kind of users. And this is covering, use cases ranging from EMBB and citywide video on the move use cases, and going to safe and smart cities, EMBB and ultra reliability use cases, whether they are for Industry 4.0 or other verticals or smart city, and also covering fixed wireless access needs. Next, please. So, yes. So these use cases here, you know, many of them require continuous high speed, continuous coverage, but also very important that is delivered in a cost-effective manner. And midbands are really key to serve that that goal. Of course, midbands can serve this continuous coverage and high-speed coverage cost effectively within cities, but they are also valuable outside from the cities to serve some use cases, other use cases like fixed wireless access, some manufacturing, agriculture, and so on and so forward. And as also already said by other speakers in previous sessions, there is low, mid, and high bands. They are complementing each other. They serve different kind of use cases, but they are not substitute each other. Low bands are there for coverage in remote areas and deep indoor environments, and high bands are so good for hotspots and some of these fixed wireless access in some of the markets. Next, please. Now, from regulatory perspective, it is very important to say that many of these use cases basically require predictable quality of service that is so unique from licensed spectrum. They require low latency, they require reliability, this continuous coverage from indoor to outdoor, vice versa, and mobility. And for that, individual licenses are key, because these individual licenses, they bring certainty with regard to the availability of spectrum. That's necessary to control interference and have this highly predictable quality of service. This certainty about the availability of spectrum is also necessary to sustain network investment. And we have heard this in other speakers' interventions also yesterday. For example, in order to have that certainty about investing in large deployments, there needs to be some individual licenses, and there needs we need to reduce that uncertainty about whether there will be interference and so on and so forward. So next, please. The next important point, and that's something that we recommend really to regulators to prioritize, is national-wide licensing. And this national-wide licensing in midbands is really important to support uniform connectivity to end users at nationwide. And that's also an incentive for network operators to invest, you know, in large deployments at national level. And that's also something that secures not only economies of scale, but also lead to a lower price per bit for the end user. And that's something that is key to deliver this affordable, you know, connectivity to the end user. Now, in terms of spectrum efficiency, I think we're talking about sharing, but very often we forget that 5G allows really millions of users, and IMT in general, millions of users to share spectrum dynamically. And that's thanks to these very sophisticated radio resource management mechanisms that are embedded in every operator's networks. And that's very good way to avoid fragmentation of spectrum. So we have different users, and these different users are served by the same spectrum resource allocated to that operator. One other point that we also recommend to regulators to increase spectrum efficiency is basically to remove the obstacles to spectrum leasing. And that's something important, basically, that might be important in some markets to serve also verticals. So next slide, please. Now I would like to present how this 5G market looks like today and how it will evolve in the future. So thanks to the lower cost per bit and this better performance of 5G that we see in the figure in the middle, especially in countries that allocated decent amount of midbands. Next, please. Next. Yes. So thanks to that, 5G is attracting really not only a growing number of users, but also is attracting more traffic indoor and outdoor. We see from that figure that 5G users in average are consuming up to 2.7 times more mobile data than 4G users. And we see that in the different markets, basically, that's starting, you know, from 15 gigabytes per month up to 36 or more gigabytes per month. And this is just the first wave of 5G. This is what happened after one and a half or 2 years of 5G deployment. In general, this is served typically through 100 megahertz of spectrum per MNO in midbands, and that's today mainly through C-band from 3.4 to 3.8 gigahertz, but in some countries that's complemented also by spectrum from 2.6 gigahertz band or 2.3 gigahertz band, for example. Now, how will this evolve in the future? We can see in the figure below on the left side that the 5G subscriptions are expected to reach 3.5 billion by 2026. And that's based basically on how on the number, which is around 200 million today. And we have seen some similarities between how 4G users were evolving between 2009, 2017, and how it started basically for 5G between 2018, 2020. There is also not only the number of users will grow, but the demand from these users is also growing. We see a figure here with an estimation from ITU report that is showing that by 2030, basically, mobile subscriptions will reach something like 250 gigabytes per month. And we have indication that that number is underestimated today for the simple reason that the estimation that has been done for 2020, which is 5 gigabytes per month, is way too low compared to what we see from the market. So next, please. So this suggests that with this growing demand, additional spectrum will be needed to serve such traffic and such a number of users. And that demand will also, that kind of additional spectrum will be needed also on these bands that serve this balance between coverage and capacity. Next slide, please. Next slide. Next slide, please. The slide before, please. Yes. So when we look to midbands, we see that we have very limited opportunities that are left for future IMT. We have seen the list presented by Alexander earlier, and what we see that we have 6 gigahertz is really a unique opportunity for future IMT. That's one band that is globally allocated already to mobile service on primary basis. That's a band that's where we see a good balance between coverage and capacity. And that's also a band which basically we have large contiguous blocks available that could allocate where regulators could allocate bandwidths of 100 megahertz or larger per MNO. And there is the agenda item 1.2 that is already basically ongoing for WRC 23. The final point is that basically this is a band where we have seen interest from different countries, and we see also wide support from industry, including leading product manufacturers, global MNO associations, and also from standard, where the work has been already started. Thank you, and this will end my my presentation.
Great. Thank you very much, Fatima, and thank you for giving us that sort of overview of the mobile industry's need for additional spectrum to improve the performance of 5G. Let's move straight on to our next speaker, who's Jennifer McCarthy. And I think we've just heard in previous presentations how much demand there is for additional spectrum for mobile. We've heard about the important existing uses for satellite. And of course, there are other incumbent users out there. And really the question is, how can we find ways of making all these uses be able to use the spectrum together, which I think leads nicely onto your presentation in terms of approaches to sharing spectrum. So over to you, floor is yours.
Thank you, Amit, and thank you Forum Global, ITU, and CITC. Really appreciate having the opportunity to bring you the perspective from Federated Wireless on how we can handle all of these competing demands for mid-band spectrum and other frequency bands. Our technology and capability is frequency band agnostic, if you will. So this same capability could be applied in lower bands or in millimeter wave bands as appropriate. But a little background on Federated Wireless. We are one of the Spectrum Access System administrators certified by the United States government to help manage dynamic spectrum access sharing of the 3.5 gigahertz band in the United States. You may have heard of this band. It's pretty famous in terms of how complicated the multiple allocations and the sharing scheme is, but we are very happy to say that we have been up and running commercially for over a year now. There are over 100,000 small cell Xenode Bs operating today in the 3.5 gigahertz band, CBRS band in the US. And we've had no reports of interference from the incumbents. So I think that is a testament to the success of the sharing framework that has been put in place. And while complex, it is working smoothly, and we're very happy with these results that we're seeing. For a little background on this, and I think it's kind of fitting given all of the competing uses for mid-band spectrum, particularly in the 3 gigahertz C-band range. The US government 10 years ago realized that if they were going to keep up with the mobile and fixed broadband spectrum demands for 4G and ultimately 5G and beyond, they were going to need to figure out a way of being more efficient in terms of introducing these new services to bands that were already occupied. They traditionally had gone through a lengthy process of looking to clear bands and then auction them off on an exclusive basis. And that clearing process could take 10, 15 years or more, be very costly and complicated for both the existing users as well as the new entrants. So they came up with a new approach, and that was to implement spectrum sharing, where incumbents can stay in the band and the new entrants can share, and we will figure out a way, depending on the circumstances of the incumbents and the geography, etc., find ways of making more efficient use out of existing bands. So the 3.5 gigahertz band was identified back in 2012 as an opportunity to implement this sharing framework. So we, as a Spectrum Access System or SAS administrator, enable sharing through our cloud-based platform and our environmental sensing capability, the sharing of 150 megahertz of spectrum that's currently being used for 4G systems, which will be migrating to 5G over 2021, 2022. The incumbent uses in this band are quite diverse. We have a significant presence of U.S. military operations. These are naval radars that are primarily shipborne, although there are a number of them that are also land-based in certain bases across the country. We also have quite a few fixed satellite systems, Earth stations, that are in various parts across the country as well. And then several hundred wireless internet service providers using point to multipoint technology to provide broadband, primarily fixed broadband access to more rural and less densely populated parts of our country. So these three different incumbent users needed to be protected as we looked to introduce new commercial mobile broadband services. So the dynamic shared access capability that we've implemented finds different ways of protecting these incumbents. The military's use being the most complicated, the most difficult to work through. And the solution that was reached there was to deploy a network of sensors along the coasts that would listen for those naval operations. And then we would direct the new broadband users to either move to a different block within the 150 megahertz to clear up a channel for the naval operations, or to ask them to lower power, or possibly to do both. The other types of incumbents, those are more fixed users, and we know where they're located, and we know their operating parameters, and end up accessing the FCC's universal licensing system, a database of those fixed users, in order to determine how best to protect them from aggregate interference from the new users. So what we have been doing over the past 5 years is certifying these spectrum access system capabilities, as well as the environmental sensors. And over a year ago, in September of 2019, the US government gave us the green light to go ahead and start operating on a commercial basis. And as I mentioned, it's been a huge success in terms of the number of devices that have been deployed to date. As I said, over 100,000 already in the first year alone, and the diversity of users that are accessing the spectrum using two different access options. One is the general authorized access tier, GAA tier, where you are licensed by rules. So as long as your equipment is certified, you can, and you have connected to one of these spectrum access systems to register your equipment and receive a frequency assignment, you can operate without having to have a license. The other access approach is a priority access license, the priority access license tier, and those were auctioned off by the FCC in August of this year. We had over 200 different participants in that auction. I think 228 licensees ended up with spectrum. Some of the big mobile network operators, a lot of the cable companies, we have utilities, wireless internet service providers, a whole range of private network operators, all purchased priority access licenses in that auction. So between the GAA tier, the unlicensed tier, and the PALs, the licensed and auctioned part of the band, there are myriad options for folks to get access to spectrum, while also providing protections for the incumbents. So together, we think that this is a great example of how bands can be shared by different users, different systems, different allocations, and yet have a successful new deployment of 4G and 5G capabilities, while also enabling existing systems to continue to operate and grow as they see fit. I'm sure we'll get into more discussion about how to handle these competing demands, but the dynamic spectrum access technology we've deployed is a successful example of how that can be done. Thank you.
Great, thank you very much, Jennifer, for that overview, particularly of the dynamic spectrum access systems. We're now going to sort of widen out the discussion to take in questions we've got from the audience. It looks like we've actually got sort of 2 or 3 screenfuls of questions here. So I think what I'm going to try and do, unfortunately we only have 20 minutes, so I think what I'm going to try and do is sort of try and generalize some of the questions. just so we can get as many as possible. And undoubtedly there'll be one or two very specific questions, which probably, if panel members could just sort of take a note of those. I know you have them in front of you, and maybe at the end, anything that we miss, perhaps respond on a one-to-one basis if we don't have time. But let's do as much as we can in the 20 minutes. So I'll start off with a question from Mustafa Abdul Hafiz Widatala. I apologize for the pronunciation. It says, the midband is most suitable for using in terrestrial services for coverage and capacity. Is it possible to refarm the whole band and leave it just for mobile services? A very radical view there. Maybe I could widen the question out a little bit to sort of say, obviously there's a lot of demand for additional midband spectrum from the mobile community, but how much spectrum does mobile actually really need? I mean, this is a very extreme view. Do you need all the midband spectrum making available for mobile? That's very extreme, but how much does it actually need? Maybe Fatima, could I turn to you first here?
Yeah, thank you, Amit. That's a very good question. That's a very good question, and the response is, is factored by different elements. So that would depend on what is the timeline you're looking at. Are you looking to the next 5 years, 10 years, or forever? And that would depend also how much midband spectrum you have today in a given country. What is the density of population in that country? What use cases that country would like to evolve to in the coming years? And also what kind of network density operators can afford in such country. So these are all elements that we think that countries need to take into account when evaluating their spectrum needs in midbands for the following years. But one indication we have seen, for example, in one of the latest reports for only V2X communications from 5G AA Association, that there will be a need for this vehicle to network communications. They would need several hundreds of megahertz of spectrum in midbands in order to serve their needs on the move, for example. But I'm just saying, if we have to calculate, depending on if we are looking to the next, for example, 5 years or so, or 10 years, we see numbers depending on the country that would be ranging from like 400, 500 megahertz of spectrum to above 1 gigahertz of spectrum of bandwidth. And as I said, this requires really a careful evaluation at every country's level in order to have more accurate estimation of that.
Great, thank you. Artie, would you like to respond in any way to?
No, I mean, look, there's quite a few questions there which are interesting, and I think when I look at Luong's question about 3.3 to 3.4 and whether that can also apply to 3.9 to 4, I would say that, the usage of satellite has really increased in those bands, especially because of decisions that have been taken in the lower part. And what some countries, for example, like Japan, have done cannot be exported elsewhere. So I think there definitely is a need to make pragmatic decisions that recognize where services are relied on and that ask the question, what is the replacement for those services? Very often for the C-band services, there is no other solution other than the satellite one.
Okay, would anyone else in the panel like to comment upon this sort of general issue of how much spectrum in Alex?
Just a quick one on that point of exclusivity, and I mentioned it in my introduction as well, because we need to find is it an exclusive band or not. Of course, midband spectrum is attractive right now if you look into the requirements defined by the mobile industry. However, would you like, and Fatima said it clearly, is it really something which is reasonable and realistic that a mobile operator will create a nationwide coverage and can afford it as well in midband spectrum, maybe above 5 gigahertz? And why haven't they done that already with an unlicensed path as well on 5 gigahertz Wi-Fi? So you see, because of the cell size there, that you have other obstacles and maybe other challenges to be adopted. And we created already an existing situation. It's not only that you need a greenfield approach for new IMT spectrum, you need to fill in the gaps to have broader bandwidth where it is needed. That requires already a very sophisticated approach to use the spectrum where it is needed. Maybe in urban areas, in rural areas, it's a different story. So you see it from a different perspective, and therefore you need to have the right spectrum at the right part of the of your geographical point in your country. From that perspective, I wouldn't say that the midband spectrum must be exclusive for IMT. It of course can be. And in Germany, we did it for 3.4, 3.8 to a certain degree, because we believe there is still an opportunity for a nationwide coverage without creating too many, without creating an opportunity for others to join in. But for higher frequency ranges, in particular the 6 GHz band, it may be a different story, and this needs to be further discussed.
Well, moving on to the topic of the 6 GHz band, and also sort of referring to sort of some of the earlier points you made just about the license exempt usage. One of the questions we've had from Ibrahim Al-Awas is, do you think that the balance between awarding IMT spectrum with license exempt spectrum, such as Wi-Fi, is an important aspect in order to increase spectral efficiency? What is your thought on the 6 GHz band? Fatima, this one was directed as you, so I'll come to you first. But one thing I noticed on one of the slides you presented, you sort of presented a slide which sort of said 5G is overtaking Wi-Fi by a considerable margin on speeds. And I sort of almost wondered, does that undermine your case for more spectrum? Does that not make the case that Wi-Fi needs more spectrum more than 5G needs more spectrum? Because 5G is racing ahead and Wi-Fi is now falling behind. And of course, we all need both, really.
That's a good question, and I was expecting it. In reality, what we see in these markets is that with roughly 100 megahertz per MNO, these MNOs are achieving much higher performance than in any of the other technologies, basically 4G or Wi-Fi and so on. If we look, Wi-Fi performance in that slide is what comes out of using 2.4 gigahertz and 5 gigahertz band. And this is something around 700 megahertz of spectrum there. So asking the question of spectrum efficiency, that shows basically that with the 100 megahertz per MNO, you can achieve really a huge amount of performance and a good spectrum efficiency. Whether there is a need for more spectrum for licensed and unlicensed, once again, that's something that we invite really countries to look to their use cases. Alexander talked about the coverage point and propagation. When we have evaluated, for example, we have made some simulations to evaluate how much coverage we can expect out of from 6 gigahertz compared to C-band. And we realized that in cities, for example, you could basically reuse the same cell grid used today for 3.5 gigahertz band. You can reuse the same cell grid for 5G in 6 gigahertz band. Now, the difference with Wi-Fi is that 5G is using macro cells. And from that perspective, from propagation perspective, we think this is very precious band, still with this good balance between capacity and coverage, and would be basically reducing its importance to say that it should be limited only to indoor coverage, for example. Now, there will be need for more capacity, both sides, licensed and unlicensed. How much that is needed in some countries, that's a special evaluation that needs to be done in that country, depending on what use cases are to be covered and whether these use cases are indoor only, whether these indoor use cases couldn't be served by higher bands, for example, higher bands and licensed spectrum, and so on and so forth. So there is no response to that fits all. But there is one thing in common that we have here is that really regulators need to take into account also these future needs and assess them carefully in order to take some educated decisions there. Because the choices, as very are now very limited to this portion of spectrum.
Would anyone else like to come in on this point of particularly sort of the wider point of the sort of balanced mix of spectrum between licensed and unlicensed use? Or Jennifer?
Sure. Yes, I think that this question is one that's coming up pretty frequently. Is do we need exclusively licensed bands? Do we need unlicensed, or is there some kind of hybrid solution that is possible? I think Alex and Vanessa in Germany have tried to find a nice balance there to support what they're doing in the 3 gigahertz band with the verticals in particular. But I think, again, the CBRS approach where both licensed and unlicensed are offered in the same frequency band is a great example of how economies of scale can be achieved within a band and give different access options to different users depending on their requirements. As I mentioned, we've got the big MNOs, mobile network operators are using the CBRS spectrum, as are a really wide range of private network users, whether those are industrial, educational, other wireless internet service providers who may not be able to afford a large regional or nationwide exclusive license, but can access the economies of scale and the ecosystem that's developed for the band because of the presence of the MNOs, but yet provide services to a particular town or a particular region or for their own manufacturing facility. So having a combination of both licensed and unlicensed, we think in the same band with the same equipment capability can be a really good way of approaching that. We're also applying the same technology to the 6 gigahertz band. In that band, we're calling it an automated frequency coordination system, but we're looking forward to working with countries that are looking to implement new services in that band while continuing to protect incumbent services. And this dynamic shared access technology can be helpful there as well.
Great, thank you. Your mention of the verticals takes me very nicely onto the next question I wanted to raise. So this was just raised by Dean Bubley, and it's actually addressed to Fatima Huawei, but I think I'm actually going to start with you, Alex, first, but let me read the question first. The presentation seems very focused on MNOs and national licensing, yet many of the use cases refer to indoor or enterprise/vertical users that don't want to use MNO services. How do you handle the trade-off between a narrow view of spectrum efficiency versus a broader view of innovation and the ability to create customized specific networks for particular user organizations? And no, network slicing is not the answer to this, Dean said. Before we answer that question, I'll give you a bit of time, Fatima, to think about that. I just want to, given Jennifer's raised the topic, and I was also going to raise this, Alexander, would you mind saying a little bit about what you've done in Germany for making spectrum available for the verticals?
Well, yeah, it's more or less that we set aside 100 megahertz from the general authorized procedure of what the general award procedure for verticals. Give it on a specific single license basis, on a first come first served basis for vertical users on a localized usage. So they need to have a local authority on their own spectrum on a particular geographical point, and there they can build up their license. So it's also called a campus network or something like that. So you can, and it's not limited only to the industry. Of course, the industry was very much interested in that one. It could also be the academic. It could be anybody else who's going into that direction. They can apply for the frequencies up to 100 megahertz. So you can really decide which kind of space you would like to use, and then you need to build up your network. There is, of course, a certain use it or lose it regulation in place where we have a check up after the first year and later on if they really use the spectrum and it's not set aside. If the spectrum is not used at this particular point, of course, it can be used by others as well, and that includes also the mobile operators. So therefore, there is some kind of give and take. We would like to ensure the efficient use of the spectrum up to 3.8, but we would like to give those who have maybe some kind of ideas, innovative approaches towards these campus networks, the opportunity to have their own spectrum and build up their own network on a localized basis. And that's not only indoor. Of course, they need to have there is certain regulation in place in order not to create interference, and network synchronization is a key part here for 5G, clear. But we need to move forward. And of course, any indoor usage is much easier to be implemented than an outdoor usage. And we are thinking about extending that one and thinking about how we can move forward to other frequency ranges as well. But that belongs to the future. And maybe we can use an automatic system as well. But that's something where we are not at this point in time.
Fair enough. Fatima, as the question was originally addressed to Huawei, do you want to comment on this?
Yes, of course, of course. So when we look to verticals, many of the verticals basically, when 5G requirements were basically defined in 3GPP, many of the verticals came to 3GPP and shared their requirements. And part of these requirements, there was basically ultra reliability, low latency, predictable quality of service, and really a big interest in deploying 5G technology. Now, this 5G technology has been designed in order to basically be able, with one network, serve different kind of users. Also, in order to improve the spectrum efficiency. Because if you are sharing same network from one operator between different users, then you can serve the public users and you can serve also these verticals. And from that perspective, innovation is something coming from also the standard itself. And as I said by Sverker in a previous session, 3GPP is doing a lot of innovation there, also based on what contributions from these verticals. So the point why basically why licenses to MNOs, we think that it's a win-win in the sense that verticals, they can benefit from a large network, they can benefit from solid investments, they can benefit from reliable quality of service, and they can benefit from the economies of scale from an operator network. If we have in a band, there is a risk if a band is allocated only to verticals and not to MNOs, that the ecosystem basically doesn't develop, or that there are not enough economies of scale, and at the end it leads to much more expensive deployment, etc., and to also delays in basically deploying such networks. So we see that it's really a win-win, scenario, and that's why we are recommending it. But in countries where there is specific really need for some dedicated spectrum, we think it should be really carefully assessed how much of that is needed in order to serve which kind of area, what power for this, how can you control this interference. It's not a trivial really exercise, this interference management. Of course, sharing is good. Sharing is good, and that's something that everybody is striving to study at ITU level, for example, between different systems and so on and so forward. But there is also this difficult exercise, which is maintaining interference to an acceptable level between the different users of the spectrum. So that's basically. I hope it's answering the question.
Yeah, I think this is one of those questions that we could have a long debate over for a long time. So yeah, I think we've got 2 minutes left. I'm going to throw one last question in there, which has come in, which is this is from Mohamed Jawad. He says, question to Alex: what is the CPT's views with regards to using the fixed services allocation to deploy 5G technology for fixed wireless access in bands already shared between the fixed service and the fixed satellite service? And I guess, Artie, I think you alluded to this in some of your opening remarks about the issue of the difference between point to multi-point systems and coordination with satellite versus point to point. But Alex, do you want to take this one first, and then maybe Artie come back? And
straight answer to that one. From our understanding, in terms of the WRC, this is an issue of how can you apply a certain technology in certain bands. And we try to be as technology neutral as possible in order to allow that. So this is a normal thing where we look for processes within the ITU, within the ITUR, to go for a quick solution. But we definitely would like to see here the studies in order not to change the interference environment between the different services. So as Arti pointed out, we need to have a clear indication that point-to-multipoint with 5G technology will not create additional interference to the FSS.
Arti, is that okay, or do you want to add anything to that?
No, I completely agree. That's something that still needs to be studied. And I think one thing which is vital to note as well is that there are alternatives. They don't have to go into the bands where we are. MNOs have plenty of alternatives to reform 2G, 3G spectrum, share spectrum, or even use millimeter wave bands in high density areas. So studies need to be done on that as well. Thank you.
Thank you. Thank you very much to all of you for your contributions there. And thank you very much to the audience for all the questions. I think we got through about 2/3 of them. So any that are left, if as I say, if the speakers can respond on a one-to-one basis, I think where they've been addressed through the private message function, that would be great. But thank you all very much. It was a really great session. And I'll hand back to Dan to take us to the sort of third topic of the day, which is, of course, the high band spectrum. So again, thank you all for a great session on midband.
Thank you. Bye-bye. Straight.